Hi, and welcome to this next video. In this video, I just want to map out from the lecture notes a few more critical concepts. We already introduced the idea that there is something called a programming paradigm. Now, you have to bear with me because it's very important that these kind of general concepts, and a paradigm is a whole approach to coding, as we said in the previous video. But actually, there's a more fundamental distinction that students need to understand between two different types of languages that you have in programming. One, which is the one that you have largely been coding in, is called imperative, and we'll explain what that is. And the other one is called declarative. And the distinction between them is quite critical, and it's important to understand how functional programming fits into this, because functional programming, and this is when I said in the first lecture, functional programming isn't simply just taking a bunch of functions and working within, say, procedural or object-oriented coding. Functional programming is a different paradigm, remember, a different approach, a different way of thinking about how code works and what it's doing. But critical to that is it actually also tackles the idea that programming languages, there are two broad types. They do overlap, and there are some that can, you can mix them up, but the concept is really critical. So let's just try to clarify what we mean. First of all, when we look at the more familiar example, so let's have a look at imperative programming. Imperative programming is what you will have encountered in quite a lot of your coding so far. So for example, in Java, you'll have bits of code like this. You'll have system out, print line, bits of text in there with a semicolon at the end. You'll have if statements, for example, that look like this. So we have these types of lines in code. What are they? Well, they are what we call statements. And the idea of the programming language is that it basically executes or carries out a sequence or a group of statements in a particular order. And each of these are, if you like, commands which operate on, and here's another critical concept, and it would be easy to avoid this, what's called the state of the program. And this is a concept that's been buried inside object-oriented programming, but maybe not made as clear and visible to you before. If you think about an object, it has member variables. And those member variables, another way of understanding the member variables is to understand them as defining the state of an object. So when you operate on them, you have a function, a method down here, and you have a method here. And when your object does stuff to the data and it's interacting and editing that data in the object, it's changing the state of that object. So you have this concept of a state. The data isn't neutral. It actually affects the whole state of that particular object. And that's true of imperative programming and this type of programming where variables affect state. What are the typical languages? Well, you will have encountered Java, you will have encountered JavaScript, I suspect by now, and Python. Three obvious examples. C is another example, C++, C#, etc. Broadly speaking, that huge family of functions that you will have seen so far. Okay, so with imperative programming, you can use imperative programming. See if I've got space on the other side. No, I haven't. So if we start with this idea of imperative programming, where we have states, we have statements and execution of them, and we can alter the state of things, you have two broad paradigms of programming associated. Now, you have object-oriented and you have procedural. And these both hang off this type of language. Okay, so we know that Java is an object-oriented language. We also know actually that there are some hybrids between procedural and object-oriented. For example, Python. Python lets you work and create objects as well, but it also has a very strong procedural element as well in the way that you code. So if you like, that's the broad familiarity. That's really a definition, a series of concepts that help you when you're thinking, what is the big deal about functional programming? It is, it involves a different paradigm, a different approach to programming, but it's also a different type of language. So let's try to just get some broad concepts out. At this stage, they're just going to feel like concepts. So as opposed to imperative programming, you have declarative languages or declarative programming. Now, I'm going to put here declarative programming, okay, of which the example you're going to be working with is Haskell. So what is distinctive about it? Well, first of all, let's grab another color. There are no statements. And you might think, what? There are no statements. Okay. And there is no program state. Now, these are quite abstract ideas. Perhaps your nearest encounter to part of this, especially the no program state, is if you ever used a class in object-oriented programming, but you never created an object from it. You didn't create an object, you simply used it in what's called as a static class. And typically what you did in your static classes, and this is just an analogy, it's similar, but it's not quite the same, this idea of no program state. So if I had a method, right, I would pass my method some parameters, it would operate on them, return, but it wouldn't change the internal state of the class because I wasn't using an object. And you will find that the concept of static, which also goes back some way, is a very similar concept where the member variables play no role in a class. There is no state to be changed. And so you have this type of method which you pass stuff to, it does stuff and returns it, job done. Okay, so when you're trying to find a way of grasping what's going on in this type of concept, there is a concept you will have encountered. For those students who will remember their first year, we had static helper functions. We had static helper functions, which did nothing but just carry out a series of tasks. Now, it's not the same as declarative coding, but there was no state involved. You weren't storing data, you weren't altering variables and then changing the state of your program. They simply carried out a series of actions. Now, that's a good way of helping you understand that with declarative programming, we have a much more radical shift here. So that simple idea of the static and what happened there gets you close to what's going on in declarative, but declarative takes it one step further and becomes the basis of the whole framework. You also have within declarative programming what's called logic programming and AI, but we're not going to focus on that. We're only going to stick to functional programming. Okay, so the takeaway from this particular introductory, before we actually write some lines of code, are to summarize. And it's very important you don't skip this. Be very, very clear. When you look at functional programming, you're looking at what's called a new paradigm. It's based on the concept of a function. It may be closer for you, as I've said right at the end of this second video, wherever I've put the notes, it may be closer for you to grasp the concept of what was called a static method. a method in object-oriented or procedural program that did not change data or variables, but receive parameters and return data and perform some kind of action on that. But that was it. The initial parameters weren't changed, and that sort of gets you close to it, but it's different. And remember, don't get that confused with using a function in your Python, or a function or a method. It is a new paradigm. It's different from procedural and object-oriented. That's critical to understand. And one last critical concept is that it's a different type of programming approach to the language as well. It's not what we call imperative programming. It is what we call declarative programming. And another example which you may have encountered is also SQL, the query language that you use for databases. This is also a declarative language. And if you look at the declarative language, it'll give you some way into grasping this. So there are some ways into what you will be doing in functional programming. But think SQL, how different SQL is from, say, Java. And that's the right approach when you're thinking about declarative programming. You are not thinking about how can I force myself to keep on thinking an object-based or procedural-based. What you need to do is take similar concepts and help your thinking move towards functional programming. Thank you.